Hello, can you hear me? Okay, yeah, it's fine. Hello, so I'll be doing acids and bases for Chem again. Not again, actually. Acid and it should be acids actually. You know what? It's fine. And I'll be doing this over 2 videos. So I'm gonna name this 1. Alright, so do your first question. And it says a swimming pool contains two megaliters of water at a pH of 7.8, making swimming in it unpleasant. The caretaker needs to reduce the pH to 6.8. What volume of 12 moles per liter hydrochloric acid does he need to add? Assume the volume of acid is insignificant compared to the volume of the pool. Okay, so from the question we know that they want us to use the pH way to solve it. So we'll just start by saying that the current pH is given by the formula pH equals negative log 10, and it's the concentration of hydrogens. And that means, but then we can sub numbers in, so 7.8 equals negative log 10 concentration of H. So we have, that's all the numbers we need, and now we have to use our calculator. So what this equation means is that 10, well, can't really do it right now, so we'll just put a negative on this side. So to get H plus, which is the concentration of H plus ions, this equation basically means that 10 to the power of 7.8 is equal to H. So what we have to do is just 10 to the power of negative 7.8, which equals to 1.584 times 10 to the power of 1, 2, 3, 4, 5, 6, 7, 8. This is moles per liter. Okay, so now we want to find the pH that we wanted. So the final pH. So the final pH is given by the same formula. Okay, now we can solve it. It will say 6.8. 6.8 equals negative log 10. Just put a negative on this side. It'll be the hydrogen concentration in the end, which means that this will equal to 10 to the power of negative 6.8. And this is equal to 1.5848 times 10 to the power of 1, 2, 3, 4, 5, 6, 7 moles per liter. And now that we have the concentration of water that we need to change by, we want to find out. So this is moles per liter. So you can see that in the beginning, every liter there's that many moles of hydrogen, and at the end we have this many much of hydrogen. We want to find how much has been changed, so then we can figure out what is the volume of extra hydrogen ions that have been added, so then the concentration increase. So we want to know the change is equal to 1.5848 times 10 to the power negative 7 minus 1.584 times 10 to the power negative 8. And we will get, so this, for easy for a calculator, this is 10 to the power negative 6.8 minus 10 to the power negative 7.8, and this is equal to 1.4264 times 10 to the power of 1, 2, 3, 4, 5, 6, 7 moles per liter. Okay, now we have this concentration of hydrogen had been added from the hydrochloric acid. So now we want to find the volume of hydrochloric acid that had been added. Excuse me. So now we want to calculate. So here's the formula for volume. We have volume equals, actually, because this is moles per liter equals to moles per liter. Well, if we want to find out the volume, we have to time them. Wait, let me think about this. Alright, so we want to find the volume. So it'll be moles over moles per liter. So the volume. Yeah, but we don't really have moles, so we can't really use this equation. Okay, yeah. But the question did tell us that the hydrochloric acid is 12 moles per liter. And we can kind of just calculate that. We can calculate it from that. We don't even need the number of moles. So if the hydrochloric acid is 12 moles per liter, we need 1.462 moles per liter. And then how much hydrochloric acid do we need for this liter of pool water? So we can just do, HCl per liter of pool will equal to 1.4264 times 10 to the negative 7. It'll be over the 12, and this will equal to 1.188 times 10 to the power of 1, 2, 3, 4, 5, 6, 7, 8. So this should be in liters now, and this is only for 1 liter of the pool. Well, there is 2 megaliters, which equals to 2 times 10 to the power 6 liters of pool water. So total HCl needed will be equal to 2 times 10 to the power 6 times the answer we got. So this should equal to 0.02377 liters, which equals to, so you divide it by, we can time it by 1,000 to make it into milliliters. So that'd be 23.8 milliliters of hydrochloric acid for this question. Okay, that's an interesting question. All right, now we move on to the next question. Okay. Next question says, pool water with a hydrogen ion concentration of 3.6 times 10 to the power negative 4 moles per liter can be relatively acidic. So we have pool water, and I have a hydrogen concentration. Okay, H plus concentration of 3.6 times 10 to the negative 4 moles per liter. And this can make it unsuitable for irrigation. Oh wow, okay. Mixing this water with rainwater reduces the concentration of hydrogen ions and hence increase the pH. Assume the rainwater is neutral. Calculate the volume of rainwater that should be added to 3 times 10 to the power 3 liters of water to reduce the hydrogen ions concentration to 1 times 10 to the power -6 moles per liter. Okay, so this thing, so it's bore water, right? Bore water. And in part A of this question, there is 3 times 10 to the power 3 liters of this. And we have to reduce the hydrogen ion concentration from this to 1 times 10 to the power -6 moles per liter. So we can do the pH way or the actual concentration volume way, because now that we have like moles, we can use them. Okay, because we have volume and also moles per liter, which is concentration, we can use the mole formula for this question. Or we can do pH, but pH is, we already did pH, so we can do initial concentration of bore water. No, initial moles. Yeah, how many moles of uh, how many moles of hydrogen ions are there in this amount of bore water? So initial moles of H plus will be N equals to concentration times volume, which equals to 3 times 3 to the power 3. Oh my god, what did I say? 10 to the power 3 times, well, 1 times 10 to the power -6, which equals to 3 times 10 to the power 3. 3 times 10 to the power 3 times 10 to the power -6, which equals to, oh, wait, no, this is initial. Initial should be 3.6 times 10 to the power -4. Yeah, because I used this instead of this. So, my bad. 3.6 times 10 to the power -4 times 3 times 10 to the power 3. 1.08 moles of hydrogen ions initially in the bore water. So now we want to lower that concentration by adding in more water. So how will we do that? Well, the moles will stay the same because there's no more hydrogen ions inside the water that we added, and so the moles won't change. The concentration we have there, we want to have this new concentration when we have to find the volume. So we're gonna do final, and this will equal to N equals concentration of volume again, but this time it'll become 1.08 equals the concentration that we want, 1 times 10 to the -6 times V. So the volume will equal to 1.08 divided by 10 to the power -6, which equals to 1080,000 liters. And that's a lot of liters. And because that's the total, we have to subtract the initial bore water volume. So the rainwater water volume. Wait, let me look at this. Volume will equal to 1080,000 subtract 3 times 10 to the power 3, which equals to, so that's just minus 3,000. 1077,000 liters, which equals to 1.08 times 10 to the power of 1, 2, 3, 4, 5, 6 liters. Alright, that's it for part A, as that's how many liters we need of rainwater. Now for part B, It asks, is this practical? Is this a practical method of reducing the hydrogen ions concentration? Explain. Okay, no. Be It's basically just because there is a an unrealistic amount of rain water needed. Is it simple to achieve a simple goal? I mean, not really. So that's basically it. This is not practical as it's not really possible for normal people, unless if you're weird, okay? I don't know. Part C says suggest another method that can be used to achieve the same result. How does this compare with the addition of rainwater? Okay, so another way to reduce the pH is by adding, instead of adding in more things that lowers the concentration, we can add things that reduce the hydrogen. So by adding a base like calcium carbonate, uh, it oh my god, effectively removes H plus ions. Uh, this is more this is more practical than adding rainwater, as not that much much reactants, not that much additional materials, resources are needed, while as this uses chemical chemical reactions, while adding rainwater just depends on the large works by having the large amount of water diluting the H plus ions, which is inefficient. Efficient. Alright, that's basically what you have to explain. It's not that bad. Alright, bye bye.